going to see a compression. And then this end, we are going to see a tensor. Okay. Then the next stage, okay, and we are going to look at moment about x, sorry, about the z-axis. So I'm just going to copy this whole diagram, wipe out a few things. Any questions so far from anyone? You can ask me now. Anyone? Hello?
Yeah, did you just calculate my and get positive 800 to confirm that your assumption about the direction is correct?
Yeah. Yep.
Oh, thank you.
Oops, sorry. I lost my mic and my headphone. Yes, I did that. Okay. If it's negative, means my direction is wrong.
Yeah, thank you.
Okay. So what I'm going to do is the next one, I'm going to deliberately guess the wrong direction. Okay. And show you. Okay. So the next one, we are going to find. We're going to find our MZ. Okay, we're going to find MZ. So MZ, I'm going to assume that the direction is this way. I'm going to assume MZ. Okay, this is the positive. Okay, I just made that assumption. Okay, so when that's the case, okay, so this is again assume. Okay, so when you do your analysis, you have to follow your assumption that over here this direction is positive. Okay, and then we are going to calculate MZ. So MZ is 150 multiplied by 0.9 minus by 500 multiplied by 0.9. This is a thing to take note is your perpendicular distance. You need to know what distance to use. Okay, and then the next one is minus 250 multiplied by 0.9. Okay, so I have a very bad habit now. On Wednesday is our wake up at 4 in the morning to watch the book of Boba Fett. Okay, it's so bad. So a bit of distraction. So this is, so now you see minus 540. Can't believe it. I'm talking about that, and it's recorded. It's okay. I don't care. Okay, it is negative 540 pound-inch. Okay, this means the assumed direction is wrong. Okay, we assume that this is positive, and we realize that, hey, positive, this is not positive, this direction is negative. So this is the wrong assumed direction. So when you get negative, what you have to do now is you have to just wipe this off. I mean, cancel it. Don't wipe off, okay? You have to cancel it, okay? And then you have to flip this side to say that this is the right direction, okay? So this is equal to 540 pound-inch, and this is the right direction. Okay, do not wipe out. Okay, do not erase and do not permanently erase. Why is that? Because whenever you do calculation like this, when you go to work next time, okay, good priorities, you cheeky sir. So, okay, coming back to here. So in future, as an engineer, when you're doing analysis like this, okay, you have to show there will be someone else above you, okay, or your supervisor or a chief engineer will look at your calculation, okay. And then when you make an analysis like this, and later on when you do correction, okay, they have to see what correction you did, okay? And that is very, very important, okay. In future, someone else design a building or a bridge that collapsed, okay, you have to look at the calculation. You have to know what they're calculating. Sometimes they make mistakes like that you can find, okay. Right, so from here, MZ over here, head of the bending moment vector is going to be compression, and this will be in tensile. Okay. Right. So now once you have everything, now we are going to calculate the stresses at point A. Okay. So where is point A in our diagram? I'll write down here that this is our point A. Then we have our point B. And then we have our point D. Okay. So now we have everything. So now we're going to find the stresses, right? Stress X at point A. So this is equal to Px over A. Okay. M y over Iyy multiplied by Z. And then we have mz over Izz multiplied by Y. So we know that this is positive because it's tensile. So the 900 that we have calculated, regardless of whether is it point A, point B, or point D, is always going to be tensile. This is the way, you cheeky sort, Matthew. You've seen it already. Then you look about a moment about Y. Okay, and then we are going to see my at point A, which I'm highlighting now at point A. Okay, more about Y. It's going to induce tensile, so this is going to be our positive, right? And then at point A from MZ, okay, so at MZ is going to induce a compression. That's negative. Okay. So the next thing that we have to determine, which we have not done yet, is we have to find what is our Iyy and Izz. So I've tested a lot of you. You guys seem to know how to determine Iyy and Izz. So I'm going to do it again. Okay. Just to quickly do a quick summary for this topic before we go to a next new chapter or new topic. So we know, I'm going to paste down here. Okay, so I'm going to find YY first. So this is our YY axis. And over here, this is our ZZ axis. Okay, so we're going to find our Iyy. Right, so the formula, because it's exactly at the centroid, so it's width depth cube over 12. Izz is also width depth cube over 12. Okay, so like how I taught you guys, okay, or girls, that, or you all, that parallel of the axis of interest, this is your width. And then anything that is perpendicular to the axis, right? So this is perpendicular to the y-axis. This is your depth. Okay. So for this case, the width, so this height is 1.8. This is 4.0. Okay. So the width is 1.8. The depth is 4 cubed over 12. Okay. So this will be equal to 1.8 times by 4 power 3 divided by 12, which is equal to 9.6 inch to the power 4. And then over here, anything that's parallel is your width, perpendicular to the axis. This, okay, perpendicular to the axis. This is your depth. Okay. So the width will be equal to 4 depth over 12, right? So 1.8 power 3 times 4 divided by 12 is 1.944. Okay, you never get it wrong. Whenever you do this, you never get it wrong. Okay, you don't start doing this a lot of times. Okay, I used to get it wrong when I was young. I thought with you see W and I about the z-axis, the formula is the same. I take it like English. Okay, width is always smaller, depth is always higher. That's garbage. Okay, I learned the wrong thing. Okay, so don't be like me. Make the same mistake. Okay, you have to be better than me at a younger age. Okay, so I'm still going to copy the whole thing over here because it's very useful to have this doing your analysis. Yeah, I think I moved this too far up. Some of the things that I'm teaching you now, okay, I only knew when I'm teaching it. I did not know when I was an undergrad. Okay, unfortunately. Right. Okay. So we have our px. So we calculated our px to be 900. Okay. So we got the direction right already. Okay, so 900. So the area we have not calculated yet. So it's 4 multiplied 1.8. That is straightforward. Plus by my. So my, we have calculated our my. My is 800. Now a lot of times we tend to make mistake regarding the z and the y. Okay, I've looked at a quiz recently. I've seen some of you make that mistake. Okay, so you have to take note where is your y-axis and where's your your y-axis and your z-axis. Okay, so if we want to look at z, it has to be running on the z-axis, right? So this is z direction, right? So z direction, this is what, 2 inch. Okay, 2 divide by your IYY, which is 9.6, then minus by MZ. So MZ we calculated to be 540, right? IZZ we have calculated earlier. IZZ we have determined it to be 1.944, and then we know that this is the y direction. Okay, so this is 0.9. Okay, so 900 divided by 4 divided by 1.8 is 125, plus by 800 times 2 divided by 9.6, 166, 1667, and then minus 540 times 0.9 divided by 1.944. It's equal to 250. So it's equal to 125 plus 166.667 minus 250 is equal to 41.667 psi. Okay. Then we're going to calculate the stress X at point D. Okay, then we know that Px over A is always constant. It's the same magnitude and direction for all. Next one is your MYY over IYY multiplied by Z. MZ over IZZ multiplied by Y. Okay, still apply the same thing. So point D is where we are concerned. So we look at moment about Y. Point D is going to induce a compression. Our moment about Y, we're going to induce a compression. So this is minus. And then at point D, okay, MZ is going to induce a tensile. And we realize that the Z and Y magnitude are the same. Okay, so all you need to do over here is 125 minus by 166.67 plus by 250. Okay. Y, I just plug in the values because the Z and the Y, the magnitude are all the same. Okay. So this will become 125 minus 166.667 plus by 250. So it's equal to positive 208.333 psi. Okay, let me look. Lucas, you have a question, Lucas?
Shouldn't my be 900? Or maybe I wrote down wrong.
Wait. Let me check. You are right. Why I put 800? Is it 800 or 900? 800, sorry.
Oh, I wrote it down wrong. That's my bad.
It's okay. I need to check also. I have to be sure. Okay. Right. Don't worry. Okay. If I make a mistake, you get pi